Good day, everyone. Today, we will talk about the chi-square test, which is commonly used when working with categorical data. Before we continue, please click the subscribe button to stay updated with my new videos. Categorical data refers to information that can be divided into distinct groups or categories, such as gender, male or female, responses like yes or no, or even favorite colors. The chi-square test helps us determine whether there is a difference or a relationship between two categorical variables. For example, it can answer questions like, is there an association between gender and voting preference? Or does color preference differ significantly among different age groups? In short, the chi-square test is a powerful tool in statistics for analyzing patterns and relationships in categorical data. The chi-square test is a non-parametric test, which means it does not require the data to follow a normal distribution. It works by comparing the observed frequencies, what we actually see in the data, with the expected frequencies, or what we would expect if there was no relationship between the variables. For example, here we see that 64 students passed when only 50 were expected, and 36 failed when 50 were expected. The chi-square test helps us decide if this difference is significant or just due to chance. There are two main types of chi-square test. The first is the test of independence, which asks, are two variables related? For example, is gender related to physical fitness test scores? The second is the goodness of fit test, which asks, does one variable match the expected distribution? For instance, if we flip a coin 20 times, do we get heads and tails in about equal numbers? So, one test checks relationships between variables, while the other checks if one variable follows what we expect. Here's an example of a chi-square test of independence. In this data set, we're looking at two variables: study method, whether students studied in a group or solo, and their performance, whether they passed or failed. For example, 30 students in the group study passed, while 20 failed. On the other hand, 25 solo learners passed and 25 failed. The chi-square test will help us check if there's a relationship between study method and performance, or if the results just happened by chance. To get the chi-square value, we enter our data into a chi-square calculator. Here we input the numbers from our data set, study method and performance. For example, 30 passed and 20 failed in the group, while 25 passed and 25 failed in solo. After filling in the table, we simply click Next, and the calculator will help us compute the chi-square value. Now that we have our contingency table, we're ready to calculate the chi-square value. But before we do, we must choose a significance level. By default, it is set at 0.05, which is the most commonly used level. However, you may also choose 0.01 if you want to be stricter, or 0.10 if you want to be more lenient. After selecting your level, simply press the Calculate Chi-Square button. This will give us the chi-square statistic and allow us to test whether the difference between groups is significant. After running the chi-square test, we now have our results. The chi-square value is 1.01 and the p-value is 0.315. Since the p-value is greater than 0.05, the result is not statistically significant. This means we do not have enough evidence to say there is a real difference in performance between the group and solo study method. The chi-square test shows no significant link between study method and performance, suggesting that study method, whether group or solo, did not make a significant difference in students' performance. That ends the presentation. Thank you for watching.